Hi guys, so I've already shot this video once. I've run through this whole thing once already, and unfortunately I just couldn't get to a stage where I was happy with the results. So this is the first outing of the new setup. Hopefully this is all going to be good. The mic is now fixed, as you can probably hear. So we're going to look at these Dynomotors and this power supply unit here. So these devices were used in the early days of radio telecoms. Radio telecoms at this point used valve equipment quite heavily, and valves have some very peculiar power supply requirements, most notably high voltages. Most vehicles around at that point were 12, 24 volts, and some were even 6. This is all 12 and 24 volts kit here. But generating high voltages using an inverter wasn't going to happen because, quite frankly, the technology wasn't there. Lower power devices used a self-exciting relay called a vibrator. These could provide reasonably low voltage, reasonably high voltages at low currents, but when it came to running transmission tubes, they just couldn't cut it. So Dynomotors came in. We'll have a quick look at this power supply in a bit. As you can see, it's very old and crusty, as is most of this kit here. But I will move this to one side, and we'll have a look at these two. So these are identical units, the only difference being that this one has some extra electronics on it. We'll have a quick look at that. That electronics really doesn't amount to much. So what we have here, and I will try with this camera because this wasn't successful with the other one, but you might be able to see it. Let's just zoom you in. You can actually see the nameplates on these this time. So there we go. Rotary transformer type 76, 10k I believe. No, it doesn't refer to the RPM. You can see the RPM there. So this is 5500 RPM. And then you've got two HT outputs, 250 volts apiece there, and 24 volts input. So this would be used for the 24 volt electrical system. This other one is exactly the same. So what happens here is we have 12 volt windings here, and we have our HT windings here. In the case of this one, they are cross connected to give 500 volts out. These are dynamos, so the output is DC, not AC. So what happens is you supply your input voltage here, 12 volt or 24 volts. That feeds the field windings and the armature on this side and spins it up as it would with any other electric motor. I can spin these ones up. I'm not going to because I don't really trust the insulation on this. I'm going to have to touch it to spin it up. I have spun it up, but I don't really... Actually, you know what? Let's give it a go. And we're back. So what we have here is a multimeter. Power that up. So I'm powering this up off of a battery. Even my big Farnell power supply cannot supply the load for this. Oh, that's a bit good, isn't it? So we'll just spin it up once. Now we're only supplying 12 volts here, so you can get an idea what's going on. Now, because the field windings are fed from the 12 volts, the second you kill the power here, this side becomes safe. Not going to test that. So we've got one side here grounded, so we're going to go onto there. Hopefully that will... I should have grabbed a set of leads with clips on. So this winding goes from here to here. It is then cross-fed across the back here by these incredibly dodgy copper cloth. I guess that could be even something fairly nasty given this, and it is cross-fed to the opposite one. Oh, it was cross-fed to the opposite winding. It isn't anymore. so we'll ignore that. So we're only going to check across these windings. So let's fire it up and give you an idea of how much current this is drawing. Also, this is expecting 24 volts, we're only running it on 12. So we have 129 volts there, 130, that's close enough to what we're expecting. And again, 130 there. So I'll shut this down because it's not particularly quiet. So 24 volts would give you your 500 volts across these two windings, or 230 volts, and these would be used to feed the transmitter. Generally not something I would consider messing around with unless you know what you're doing. This is capable of doing you damage. Although the current output is probably fairly low, that's going to depend on how much power you feed in here, and as you can see, those terminals aren't exactly small. They will take a fair amount of current through those terminals. So you've got the ability of your primary supply of the current supply ability of your primary to take into account, but you've also got the fact that there is the best part of probably 2 or 3 kilos in there that is spinning at high speed. So this is going to be able to deliver quite high pulses of current. What could you do with it now? Not a great deal. You could, in theory, put these two windings in series and use it to run anything using a switch mode. It's probably not a wonderful idea. However, you know, with switch modes, everything's rectified anyway, so DC wouldn't necessarily do it any harm. Long term, you might not do it any favours. Most switch modes are auto range, so you could probably get away with just running on one of these outputs. But really, in today's world, there's not a lot of use for these when you consider that a comparable output inverter is half the size of this, if not even less. But they're a nice piece of old equipment. We'll just bring the other ones in. I'll have a quick poke through them. And I will grab a poking stick. And we'll just get you refocused. So underneath this is exactly the same motor. It's obvious that the wiring on this isn't quite as simple as you would think. If we just focus down on this end again, you can see we've got some kind of sense wiring or low current wiring here, and more of this cable. I believe this is cotton, or possibly even glass fibre, I'm not sure. The age of this, it could be something nasty, so we'll treat that quite gently. Also interesting to see here that I don't know, can I get you zoomed down on this? Yes, I can. Let's just... So you can see there that rather than the potted epoxy on a modern motor or something similar, this appears to be cotton, and it is soaked in a glue of some kind, but it is most definitely cotton. So again, it's the way these things are made. You can see the original bars on the commutator there as well. And then let's zoom you out again. Manual zoom, unfortunately. So we come back over here and we've got some electronics on the back, but I'm fairly sure this is all just filtering. So we have, if we tilt you up a bit, these are chokes. There are a number of them, and as far as I see, so we're bringing in the high current feed here. This comes straight in. There are some very old looking potted caps here. These are actually metal. They are soldered on the back, and then I'm guessing the case forms one terminal. You can see there is a solder joint there, which probably means that runs down the centre, and then you've got a stud on the other end. God knows what state they're in, as if they're any good. I'd imagine they are long gone. They do look a bit wet and gungy down there. A lot of this stuff was sealed with wax and paper as well. And then if we flip over here, sorry, my monitor's upside down. Again, we've got some more electrolytic caps there. These are aluminium. More of this strange wiring. And then more electrolytic caps here. So my thoughts are, and I can't get any information on this one, unlike the other one, that we have an input here, an output there. The input does appear to consist solely of heavy terminals coming in. The output of those 4 pins, 3 are used, and just looking at it, it looks like we've got a HT output there, and then we've got something else on this pin, but without the circuit diagram on something this old, it really is quite hard to know exactly what's going on. So we'll put that one aside. Oh, and get this one in. Put it on its side so you can get a good view of it. Much easier if my monitor's the right way up. I may have to move my camera a bit. Bear with me. So we've got a little bit more information on this one. Not something you normally get with something this old, but we actually have an upside down circuit diagram. So we'll have a look at that in a minute and compare it to what we see here. But this unit, as you can see, has been really hacked about. So there are bits missing from this which people have tried to circumvent, and I don't know that it's really worth saving, to be honest. It is filthy. It is as bad as it looks on the camera, and we've got missing bits. So underneath you have your dynomotor again, so that is a different type again to the one that we've just looked at. There we go, you can see it in here. This is all around here. The other reason for not wanting to really think too hard about saving this is these are paper electrolytics, so the odds of them are being any good are slim to none, and there's a lot of them in here, including there, where are we? This absolutely enormous one up on the top here. I don't see any signs that it's leaked. There may be aluminium under there. I think there possibly is. Yeah, so there is aluminium. That's more of a sleeve. But again, this one's been dinged. You've only got to look at the state of it. It is absolutely filthy. So we mentioned vibrators beforehand, and that's what this uses along with the dynomotor. So the idea is this is part of a post World War II set, only just post World War II. These were in use at the end, and oh, we've got a 12 volt and 24 volt switch there. I believe that is actually on the circuit diagram. Will it focus down? It should do. There, 12 24 volt switch there. Anyway, I digress. So the idea is this contains a vibrator and a dynomotor, and you would run the radio normally from the vibrator. You can actually select via a switch on the here which power source you're going to use, but my understanding is the transceiver can override this as well. So for reception, where you basically need very little current for the vacuum tubes, it would run on the vibrator. The vibrator drives a transformer. Let's just flip this on its side again, and now it's upside down, or it will be upside down for you. So we have our input here. This comes in. Here's your vibrator here, and it is quite literally a transformer where the coil is fed by the contacts. So your power comes in here, and where we got it feeds power. Try and work out how this goes, because it's not the way I would do it. Yes, so we're feeding power straight through the relay. The relay draws power through the relay, through the transformer. The transformer provides a ground path that energizes the coil. The contact pulls in, that breaks the circuit, and then obviously the coil is no longer energized and it drops out. It carries in a circuit through a transformer. This is very similar to the kind of circuit you do if you're doing transistors, and that provides an output there to a rectifier, cold rectifier tube, which is one of the missing parts. We have some filtering, and then off it goes to the radio. It actually goes out via this big switch here and this big relay, which I think I'll cover in a second. The relay is what I understand the transceiver uses to switch between vibrator and the dynomotor, and down here is your dynomotor. This one being slightly more complex, we've got multiple connections to the field and armature windings here, and that's how that switch depends on whether you're running on 12 volt or 240. It looks like it switches between series and parallel. I didn't actually explain how the dynomotor works. So you've got your 12 volt motor spinning away at 5500 RPM there, and your magnetized field windings. And then we have two other armatures here. This one actually has 265 and 540 volts out. So these are many fine turns, which then act as a generator in that magnetic field, which, because of the higher number of windings and in there, induces a much higher voltage. And then it looks like we are feeding a set of filters, a 1 amp fuse. So 1 amp at 540 volts, if you consider that can obviously deliver enough power to blow that fuse, that's really going to make you regret that you touched it. So you really wouldn't want to touch this. 265 volt fuse, it feeds another fuse there, 1 amp again, into this switch and relay arrangement. That relay is utterly epic, and we'll have a look at that now. There we go, we're back. Not sure I trust the white level there, but apparently it's fine. So we have here our missing cold cathode rectifier. So would that be mercury? I'm not sure, I'm not up on valves. That may well be a mercury rectifier. I wouldn't have thought so, not in this kind of environment. So maybe neon or something like that, used to give the rectification. This is your vibrator socket here, and obviously it's gone. So both of these components are available. I can get them. They're not actually expensive. To get both of those would probably cost me under about £30. But again, I don't know the state of the electrolytics here. We have wiring here that's been modified. That's in no way a good thing. I could use the circuit diagram and go back to the way it should be, but it's no use to me. It's of use maybe to a collector or an amateur, but there's nothing I'd use this for. It's just an old, interesting piece of kit. So we've got your cold cathode. I can't see this, I'm using a monitor to do this. You've got the cold cathode rectifier here, you've got the vibrator. This is the transformer for that rectifier, a nice encapsulated shielded thing. I can only guess at the amount of RF noise that would kick off, and that probably explains all the filtering. No idea, because nothing in here is labelled, so I can only assume that is the filter capacitor. And then this horrendously complicated thing is the relay. And I've just noticed it's actually a rotary type. If I just push that, you can see. So we've got multiple contacts here. Again, concerns for restoring it. These look like broken edges. There's something not there. There's also something not here. So we're missing parts on this relay, so that relay would need to be replaced. We've got a socket underneath that doesn't go anywhere, so it's not really worth it. And again, a modern inverter of this size would deliver kilowatts of power. The 2 kilowatt inverters we install in emergency service vehicles are smaller than this, and they're certainly lighter. So yeah, I don't think it's worth really my time to do anything with it. But there's a bit of a look into some very old technology on how you would get high voltages from 12 volts, and yeah, it's a shame the condition it's in. I will flip it end up. Hopefully you'll have enough field of view to see it. I'll get you there in a minute. So yeah, the camera could do with going higher up. These connectors are all Bakelite. You've got a bail over there. I think the other end of that is around somewhere. This has been rewired. So there's the other end of that. That goes in, and then your bail comes over there. I've got no chance of getting that over there. Oh no, there we go. And again, turn your hand so you can see the whole connector. This has been quite comprehensively monkeyed with as well, so that's not the correct wiring for this, and believe it or not, it actually comes apart really easy. Get this bail off. And for those that are interested in this kind of stuff, there is your proof that this is ex-MOD. You've got the Pusser's arrow there, or War Department logo as others like to call it. I will just quickly pop this open because, again, it's an old style connector. It's not something that we use anymore. Let's just bring it down. And quite frankly, this is one of those things where I'm quite glad we don't use this kind of technology anymore. How did we do this? I think it hinged up from the back. There we go. So you can get an idea there of the state of things in there. So yeah, there we go. An old way of getting high voltage to drive things. Utterly obsolete. With a lot of these things we tear down, let's just bring it back. With a lot of these things we tear down, their life is effectively over at the point we tear them down. It's very rarely we do anything with them, which seems a shame for this older kit. I've had people ask about some of the things we've torn down. So if there is anything that you are interested in or you'd like to offer a home, drop us a comment and we may be able to do something for you. If it's not already got a home, there are limitations on what we can do. For example, the radar teardown we did, I wouldn't be comfortable rehoming the magnetron because, quite frankly, without everything else that's there, it's quite a dangerous bit of equipment. So, but certainly, if anyone out there thinks that they can offer any of this lot at home, give us a shout, because quite frankly, it's in my way and I don't have the time to collect this stuff, and it would be nice to know it's getting used. Anyway, first video on the new rig. Hopefully it's been a good one. I will get this edited and uploaded. Take care.